Welcome back. Today we'll discuss about trust and pressure. First, what is trust and what is pressure? First, we'll study about trust. When we push inside the pin, drawing pin, we apply force. That force is directly proportional to the plane area. Therefore, the force acting on an object perpendicular to the surface is called thrust. And thrust is a vector quantity. The unit of thrust is same as the unit of force, that is Newton. Once again, thrust means the force acting on an object perpendicular to the surface. It is called thrust. We will study about the thrust with example. You can see that the camel, they have big foot, or even the vehicle, the rear vehicle of a lorry or truck. It is big. When we walk in the sand, our feet used to get inside the sand, but if you lie down, you will not sink inside the sand. Why? Because the force exerted by your feet is small and the force exerted by your body is big. How is it happen? To understand this, the force acting on the sand, which is perpendicular, the area is small. Because of that, your feet sink when you walk in the sand. But when you lie down, the force acting perpendicular to the sand is great. It's big. Because of that, you don't sink in the sand. In short, we can say that the effect of force, that is thrust, of the same magnitude of different area is different. Lesser area, the more the effect of the thrust. That means if the area is small, the thrust effect is more. If the area is big, the effect of thrust is bigger. Therefore, I hope that you can understand why our foot sink when we are walking, but if you lie down, you will not sink, because your foot, the area is small, but when you lay down, the area is big. Therefore, in short, we can say thrust depend on the area of force applied. Let's learn with other example. When we hit the nail, it enter. Once again, what is thrust? The force acting perpendicular to the surface. Let's take another example here. When you have to insert the pin, drawing pin, when you press it, the force acting on your palm is big, but at the sub end, it enter easily. To understand more, we can take an example. If you put your pencil between your finger and press it together, what will you feel on your forefinger and thumb? Yes, you will feel pain on the forefinger because it is pointed or the lid is sharp. The thumb and the finger, they experience different force. In spite of that, you apply equal force. After you release the pencil and when you observe your finger, then your pointed finger or forefinger, you will see the hole. That means slight depression will be on your forefinger. That means more depression on your forefinger and less depression on your forefinger. Okay, pressure means it is the force per unit area. Pressure is force per unit area. In other words, we can say pressure is thrust per unit area. Let's take another example. When there is more, pressure is less. And if there is less, then pressure will be more. Therefore, pressure is inversely proportional to the area. we can just check back. When you apply equal forces, then the plane is also it affected by the force. The depression on the index finger is more because the area is small compared to the area of the thumb. When there is less, pressure is more. When there is more, pressure is less. To understand more about the concept, we'll just take another example here. If you compare the thrust between these two girls, the first girl who is standing, it sinks because the area is small here. When she's walking with the feet, it sinks because the area is very small here. You can see it here. And on the contrary, if she lie down and the area is becoming big here and she did not sink. The area, while comparing these two, the area which is small, it go deeper inside the sand, and the area which is big, it does not sink in the sand. In spite of that, the thrust is same on both these cases, but the effect are different. Same force, there is thrust, but the effect is different. Therefore, thrust per unit area is called pressure. Thrust per unit area is called pressure. Pressure is thrust per unit area. And the SI unit of pressure is N Newton square. Once again, the unit area of pressure is Newton per square meter. SI unit of pressure is Newton per square meter. And the unit of pressure is termed as Pascal, PA. Please stay tuned. We will continue in the next class about the upthrust or buoyant force and buoyancy. Thank you.